The third lab is about 3D printing and specifically talking about additive manufacturing. As you know, additive manufacturing is a very brand new manufacturing method which is more efficient, and in some areas it is very reliable and very precise to make the parts by adding material layer by layer. So recently they started to do 3D metal printing by using laser technology and metal powder. But what we have here is one of those industrial 3D printers. So how the 3D printers and additive manufacturing work, I'm going to share with you guys a couple of documents and videos that explain additive manufacturing, specifically 3D printing. So what we have here, we can create different parts by using 3D printers. So you need to use one of the CAD software like SolidWorks, and you create your part there. The output part from SolidWorks, part design, you could use another open access software which works with the 3D printers. Probably one of the very common software we have is MakerBot. So MakerBot software is the software going to get your SolidWorks file and going to transfer it to another file based on layer and coordinates, and the output of MakerBot going to be the input for the 3D printer machine. So 3D printers has different type and variety. They started very on price. You can get a plastic 3D printer for $200-300, and for those like what we have here, probably $40K, $50K. Some industries, they need to produce parts that they need for the machines, so they don't outsource it anymore. They have one of those 3D printers and they are going to create their own part that they need. So as I said, they are very reliable. So material we have here, there's going to be a gun inside, there's a platform, and there's a gun coming with PVC material. There's different material, 10 or different material that they use in order to make the 3D parts. So the gun going to heat up between 300 to 400 degrees of Celsius, which is the melting point or deformation point for my plastic material. And then they're going to start to make the part based on the output part that you created from your software. So those are coordinates actually. It's going to move like coordinates and create layer by layer of the part. So one of the important things that we have here is the model orientation. You could install that vertically or you could install that horizontally. So it depends how you're going to put it there. You are going to get the different results. It depends what is the application of your part. If your part going to use and apply force and load on it, because it's created layer by layer, your layer should be in a way that they don't have any parallel component with the force that you're going to apply. Because if there is any parallel component, that's going to break very fast because it's created layer by layer. Other important parameters that we have in the 3D printers is gravity effect. As you know, we are using molten material. Not really molten material, but deforming. So that deforming material, gravity effect, going to change it very fast. For example, if you are going to make that inside your 3D printer like this, if you don't have any kind of support under that, at some point when the material sits here, the time between material on a platform and cooling down going to cause some deformation if we don't have proper support. So normally when we have a part inside our 3D printers, based on the orientation, we are going to define a support. So it means that there is two guns over there. One gun going to start to make the support first, and the other one going to make the material. Normally it comes in two different color and two different materials. For example, for this one, when they make the part with the support going to solve in some sort of, I believe, acid solution. So they are going to make the pool of acid, and after that put the part inside that, and it's going to take, depends how much support we have, probably from 1 hour to 5 or 6 hours to solve all those supports inside the solution, and then you have your part. And in some printers they use the same material, and then you need to use the wire cutter to cut those and try to finish it very nicely, and you can have your part. As I said, the variety of application of the 3D printers these days is much, and we could see them in different industries they use. And the best and important characteristic of using additive manufacturing and 3D printing is less waste material. Because in old-fashioned method like CNC machines, you have your raw material and you start to shape it by removing material from the ground, so you create some waste over there. But here, when you create your part layer by layer, it won't be too much waste, and it is very economical. But at the same time, in some applications, still they need to work on it and make it applicable. But in most of the engineering applications, now we can see the 3D printers. So about lab 3, I'm going to share this video with you. There's some documents, PDFs, and there's 2 more videos about, in general, additive manufacturing, the history, how it starts, and where they started additive manufacturing, and how we get to this point right now. And then after that, there's going to be a couple of questions for this lab in the lab handout that you need to answer and give your point of view. And that gives some idea about additive manufacturing, and probably later on in the next year or next courses you are going to use this printer or 3D printing and make some interesting parts. Thank you.